Now that we've talked about how to interpret the correlation coefficient, we're going to go about looking at how we can calculate the correlation coefficient. The formula for the correlation coefficient looks really ugly, but don't panic here at the beginning. I'm going to help you out as we get through this video. So the formula for R, the correlation coefficient, how strongly connected the x and y variables are, is given by this formula. We'll do a parentheses around the numerator of this fraction. N, which is the sample size, is multiplied by the sum of the xy products minus the sum of the x's times the sum of the y's. And that's all in the numerator. Then in the denominator, we'll put parentheses around this as well. We'll have a square root for the sample size times the sum of the squares of x minus the sum of the x's squared times the square root of n times the sum of the squares of y minus the sum of the y's squared. And we'll close the parentheses on the denominator. Now that formula looks big and scary. On the one hand, though, you do not need to memorize it. It will be given on a formula sheet. But there's actually on Excel an easy way and a more difficult way to calculate this. I'm going to show you both ways on Excel because the more complicated way to calculate this actually sets up something we're going to be seeing later in this chapter. But both ways work just fine. So on Excel, we can go through the steps to find the sum of the x's, the sum of the y's, the sum of the x squareds, the sum of the y squareds, and the sum of the x times y products. And then we can use the formula. So let's look at this and how it works doing an example on Excel. Here in Excel, I have some data. In the first column, column B here, I'm listing the number of missing assignments several students had in the class. In the second column, column C, I'm listing the grade they got on the unit exam. If we treat the missing assignments as the x and the exam as y, what we can do on Excel is we're going to make another column for all of the x squareds, another column for the y squareds, and another column for x times y. So Excel can do this all automatically for me. I can hit equals in the first cell, click the x, Shift 6 will give me the caret or the exponent key, and 2. And when I hit tab, it's going to square that first number. We'll do the same thing for y squared. I'll hit equals, click the y, Shift 6 and 2 to square it. And when I hit tab, I end up with that y value squared. For the x times y, I can say equals, click the x, and use the star key, which is Shift 8, and click the y, and that'll multiply the x times the y together. Now what I can do if I select all three of those, I can click the dot in the bottom right corner. Double-clicking that dot will copy that formula down, giving me all the values for x squared, y squared, and xy. Now what we can do is we're going to make a row for all of the sums of each of these columns. So under the x column, the missing assignments, I can say equals sum for sum, open a parentheses, and select all the values in the x column. When I hit tab, it's going to add those together. This value is the sum of my x's. Now I can grab that dot in the bottom right corner, and I'm going to drag it to the right. We can't double-click because double-clicking goes down, but I can drag it to the right, and it's going to sum up each of those columns. Now I'm ready for my formula. And I could do this on the calculator, or I could do this in Excel. Either way works. I'm going to say equals, doing it on Excel. Open a parentheses for the numerator. N is the sample size. I can see there are 6 numbers in my chart if I were to count them. So 6. Then I need to tell it to multiply. That's going to be Shift 8. Times the xy sum. So I'll come over here to the xy column, and I'll click the sum. Minus, next is the x sum. So I'll click the x sum. The x sum is the 17. times the y sum, which is the 466, and then close the parentheses on the numerator, divided by, open a parentheses for the denominator, SQRT for square root, open a parentheses, n is the sample size, which is 6, times the sum of the x squareds, that's the 67, minus the sum of the x's, and I want to square that answer, so we'll do shift 6 for the caret, and then 2, close the parentheses on the square root, times another square root, open a parentheses, 6 is the sample size, times the sum of the y squareds, minus the sum of the y's, and then I want to square that with shift 6, close the parentheses on the square root, close the parentheses on the denominator, and when I hit enter, it's going to give me that correlation value of negative 0.69208. Now, because it's negative, you recognize that that's a negative correlation, meaning as one variable goes up, the other variable goes down. In other words, more missing assignments means lower exam scores. Fewer missing assignments means higher exam scores. Negative means it goes down. 0.69 is also between 0.6 and 0.8. And so I could even say not just that this is a negative correlation, but using our interpretation from the previous videos, we can say this is a strong negative correlation. So there does seem to be a relationship, a strong relationship between missing assignments and exam scores. I did mention that there are two ways to do this correlation coefficient on Excel. The second way is easier. The first way, though, was nice to see because it's actually going to set up something we're going to see later in this chapter. But the easier way to get to it directly without having to find all the individual sums and values is on Excel, we could just type in equals CORREL, open a parentheses, and then we select the first list, comma, and then we select the second list, and then close the parentheses. Let's take a look at doing that with the problem we just solved. So rather than doing all the work that we just did using that formula that I've copied on the screen, I could have instead just typed in equals CORREL, open a parentheses, and then selected the missing assignments, comma, selected the exam scores, closed the parentheses, and when I hit enter, you see it's going to give me in one step that correlation coefficient of negative 0.69208. Again, giving me that strong negative correlation. We have what R is equal to. Most of the time in practice, you're probably going to use the second method, the equals CORREL, and then the first list, comma, the second list. But I wanted to show you the setup for where the formula comes from because it's going to help us with something we're going to see in the rest of this chapter. Before we wrap up, there's one more thing I want to take a look at, and I want to look at this thing called the coefficient of determination. And we represent the coefficient of determination as r squared. And in fact, it's calculated by just squaring the r value. And then it's usually expressed not as a decimal, but as a percent. So for example, in our problem, talking about the relationship between missing assignments and exam scores, we found out r was equal to negative 0.69208. And we interpreted that to mean we had a strong negative correlation or relationship between the x values and the y values. We could then say, OK, I'm going to square that answer. If I do negative 0.69208 squared, we'll end up with 0.47897, which is going to round to 90. And this coefficient of determination is going to measure the percent, leave a little space here, it's going to measure the percent of variation in y explained by the variation in x. In other words, for our problem, we found out r squared was 47.9%, expressed as a percent. What that means, how we're going to interpret that, is 47.9% of the variation in my second variable in exam scores is explained by the variation in x, the first column, missing assignments. So we can interpret r squared tells us the variation in that output, that dependent variable, that is explained by the input, the dependent variable.